So today we're going to talk about Nest. Now, first question, of course, is what is Nest? Nest is a set of tools to help people create forks of Flutter. It's a repository structure. It's a collection of GitHub actions and workflows. And it's an approach that helps you build on top of Flutter instead of completely forking Flutter. So Nest was created by me and Matt, and we've also had contributors such as Leo, who runs FVM, and Victor helped us with some of the work to get the Flutter engine or the Flutter binaries compatible with Flock. So the first question is, why might you want to fork Flutter? You know, when Matt and I decided to fork Flutter, it was considered a fairly controversial decision that made a lot of people on the Flutter team upset. But I think there are very valid reasons why you might want to fork Flutter, why you may be in a similar situation as myself and Matt were. I think one of the very first reasons that you might want to fork Flutter is you may have a need to fix bugs faster than the Flutter team fixes bugs. If you're like me, you have applications running with Flutter in production, and you may run into an issue that's causing your application to crash in production. Or maybe you run into a bug in a new Flutter release that is causing bad behavior in your application. An example of this would be a while back in our application, we added a text editor. We wanted people to be able to edit source code. And quickly after we added the text editor, we found a bug where when you would drag your cursor, and this was in Flutter Web, it would select the wrong lines of text. Now, it turned out that this bug was a bug in the Flutter engine, but this bug was a bug in our application in production. So now we have a few options. One, we can file a bug report on GitHub and hope that the Flutter team fixes it. Now the problem with this is our application is broken in production today. And if we file a bug in the Flutter repo, most likely it's going to be labeled as a P2 or a P3, which may mean it takes a while for the Flutter team to get around for it. In this case, the Flutter Web text selection had been broken for years. So there was not a high priority for the Flutter team. They didn't feel like fixing it. But we were having the problem in production. Our customers needed it. And various projects like the Flutter Quill library were also having this problem in production. So using Nest, I was able to fix this problem myself, get a release out internally into production within a week, and then eventually that patch did land back in the main Flutter, but that was a few months later. And so one of the reasons that a lot of companies end up running on their own Flutter forks from time to time is that the timing and the need to get fixes to their users, it does not always align with the Flutter team's priorities. Another reason that you might want to fork Flutter is that the Flutter team won't always accept your changes. So a lot of people who have tried to contribute to Flutter have expressed frustration because the Flutter project is top-down driven. It's not like a lot of open source projects where a lot of open source projects are very, very accepting of contributions. But the team at Google is not always very accepting of contributions. Sometimes it can be frustrating to even get them to look at a change. An example of this would be while we were working on Nest, we found a bug in ET. ET is a tool that's used by the Flutter team to build the engine and run tests. Now, we found a bug that was preventing us from running the tests in the repository using ET. So I put together a pull request, I submitted it to the Flutter team, and they immediately closed it and said, no, we won't accept your change because ET is an internal tool. Now that, I didn't understand that because it's in the repository. We were running tests in the Flutter source code, but this is something that many people have experienced. And so in our case, we needed ET to be able to run these tests. So our only option, once the Flutter team refused to merge our change, was to continue running on a fork. Another reason you might want to fork Flutter, the Flutter engine and the Flutter team have committed to supporting a very limited set of operating systems, and they will not add more. They are not interested in taking on any more work than they're already doing. So what happens if the Flutter team drops support for your device? Or what happens if the Flutter team won't start support for your device? In these cases, it's very likely that if you want to use Flutter, you will have to run your own Flutter fork. Another reason you might want to fork Flutter is to access platform APIs that Flutter hides. So the Flutter engine has a lot of power in the libraries that are assembled to build it. But often, even though that functionality is already there, there's no way for you to tap into it because it's not exposed in the public engine interface. So an example of this might be Flutter Web texture rendering. We have a product that does video conferencing, and we use Flutter. And we had a bug where when you would add more than 4 or 5 videos in Flutter Web, the renderer would crash. This happened because of the way that web browsers and platform views work. Now, the way that Flutter Web handles platform views creates a problem because the web browser itself can only support 16 WebGL contexts. And every time you have a platform view, the Flutter engine on web will use one of them. And to make matters worse, when we first encountered this issue, the Flutter engine had its own limit of 8 contexts that it would expose. So after about 4 or 5 videos, the renderer would crash. Now, in order to fix this, we had to change the engine so that it didn't create platform views in the first place. We needed to render the video straight into the canvas. But of course, this was a change that required us to go into the engine and add additional APIs to be able to do this. Matt, in his experience, Matt maintains Super Editor, which is one of the most popular Flutter frameworks for building rich text editors. And he's had clients that need to get access to the IME. And unfortunately, the way that Flutter interacts with the IME does not allow third-party packages to hook into the IME. So if his client needs to do this, he has no option but to fork Flutter. Another case might be, and this is another one that relates to Super Editor, the Flutter engine itself has a lot of information about glyphs that it uses for text rendering. But the Flutter API has virtually no APIs for you to get glyph information. So let's say you're doing something like building a rich text editor, and you need access to glyph shapes or additional information about glyph metrics. You could either include a third-party package, which might significantly increase the size of your bundle, or you could fork Flutter and expose those APIs through the engine and call them at a higher level. But in each of these cases, the only one of these that I was able to get the Flutter team to have any interest in accepting a pull request for was the Flutter web texture rendering. And I think it took about 9 months from the time I submitted my pull request to the time that it landed in the engine. Which obviously, if you're shipping fast, waiting 9 months to get a fix to your customers is a really long time. So why we created Nest? Biggest reason, at least for me, is what happens when your app breaks in production. You know, the Flutter team only does a stable release every 3 months. And so, as I mentioned before, you can file a bug report or you can fix it yourself. And even if you get it merged immediately, it can take a long time to get into production. In fact, if you submit your PR close to the end of a release window, the minimum amount of time you're going to wait till it hits the Flutter stable is 3 months. Now, some people will go and use maybe the master branch of Flutter. But the challenge is, if you use the master branch of Flutter, you're getting new changes from the Flutter team every day. And the master branch is not tested as well as the stable branch. And so on any given day, if you're doing daily builds against master, your application might break. What you really want is the current stable version of Flutter plus your fix. And unfortunately, the Flutter team doesn't offer a good way for you to do that. So we created Nest as a way to make that process simpler and allow anyone who needs to build a custom variant of Flutter to do so with a lot less manual work. Another reason we created Nest was that if you talk about things like CI builds, these are things that can take a really long time. And they're things that a lot of developers don't have a lot of experience doing. And so, for example, on my team, the very first time we fixed a bug in the Flutter engine, the fix was a lot easier than building all the CI so that we could use the fix in our app. And so we created Nest so that people would have an easier time getting things like a continuous integration set up to build their own Flutter framework or engine builds. Another reason is that you can fix a bug in isolation on your own machine fairly easily, but you need to be able to distribute that build to your team at a minimum and maybe to the rest of the community so they can use it as well. And again, this is another problem that, even if you understand how the engine works fairly well, even if you understand how Flutter works fairly well, this is another problem that you're going to have to solve in order to actually use your changes. Another reason that we created Nest is that the Flutter team itself uses a system called Cocoon to build Flutter. And I don't know if anyone here has heard of Cocoon, but Cocoon is a specialized continuous integration system built, I believe, by the Chrome team to build Chrome. The challenge is almost no one outside of Google uses Cocoon. So if you want to take advantage of the same system that the Flutter team uses to build your custom fork, you'll have to go and set up and maintain Cocoon. But we wanted to have a way for people to use standard things like GitHub Actions to do their CI instead of using Cocoon. So how does Nest work? When we first started the project, we asked the community, how do you think we should handle patches? because one of our goals with Nest was that we want to always leave open the door that someone could work with the Flutter team and merge any of our patches back into the Flutter engine on the master branch. And so we asked around, and someone in our community suggested, why don't we take a look at the way Electron manages patches to Chromium? So Electron has a problem that many of the patches that the Electron team needs to make to Chrome are never going to be merged into Chrome, because by their very nature, they're trying to do something a little bit different than the Chrome project is trying to do. And so we took a look and said, okay, well, how does Electron manage patches? And in Electron, what they do is they have a patch folder. And every time that they need to patch Chrome, they drop a patch in the patch folder, rather than maintaining their own separate forked Git repository of Chrome. And then they have two commands, git import patches and git export patches, to assist in the creation and in applying those patches. Now, one of the nice things about this process is that it enables you to maintain the patches in an isolated way. And it's a lot easier to take those patches, distribute them to other people, or potentially contribute them back to the Flutter repository. Now, while what Electron does is good, the problem was, for our purpose, we needed a few customizations to enable this process to work a little more seamlessly. So one was that we needed to update these Electron commands to support a custom patches location. So it would be really easy to take these patches and apply them to your repo. Another thing we had to do was we split out the patches for Nest from the Flutter repository, because our idea with Nest was we want people to be able to apply their own set of patches on top of Flutter, not necessarily have to use the patches that we feel we need or the official patches that we have in Nest. And then another problem that we needed to solve was, how does this work when you need to support multiple branches? So if you think about Flutter, Flutter has stable, master, and beta branches. Now, at any given moment in Nest, we want to make sure that our patches can be applied to as many of those branches as possible. Now, they can't always be applied to all the branches. Often, we might need to fix something against the master repo due to changes that were recently committed to Flutter, and the changes that it relies on don't even exist in stable. And so we needed to take the concept that Electron uses, but fit it into this environment where the Flutter team themselves has 3 separate branches that they really maintain. So Nest has, to make this process a little more streamlined, Nest has a collection of GitHub actions and workflows. These actions and workflows can be used to take the Nest patches, reapply them on top of one of those branches of Flutter, like stable or master or beta, and create your own new repository that has those patches applied on top of that branch. Now, in Flock, which is our fork of Flutter that uses Nest, every day what we do is we apply these branches and our set of patches for each of these branches on top of what is in those branches in the master Flutter repo. What's nice about this is we know as soon as the Flutter team merges a change into master or beta or stable that breaks Flock or breaks Nest, we're immediately notified. And to me, this is much better than a case where maybe you just go into GitHub, you fork the Flutter repo, and then maybe you have a process occasionally where you try to merge the changes from the Flutter team in. being able to get notified immediately when these things break is really nice. Because even if maybe you don't immediately have time to address the issue, you immediately know that something in the Flutter repo has diverged from your fork, and you can start taking a look at what it would take to fix your patches. So challenges that we faced. One of the biggest problems we were trying to solve is how do we avoid forking the entire ecosystem? How do we avoid getting in a situation where packages on pub/dev would maybe only work with our fork, but not work with the master Flutter fork? How do we make it very easy for people in our community or people in the Flutter community as a whole to take our patches and apply them back to Flutter? We didn't want to end up with a fork where it was very, very hard to tell what were the changes in the fork and how has it diverged from Flutter itself. Another challenge we faced was because we maintained a selection of patch files, how do we create and review them? Because in our case, we're on GitHub, and one of the things we noticed is you can't even use the GitHub user interface to edit patch files because the GitHub interface is a little bit broken when it comes to editing and reviewing patch files. And so Matt is currently working on a patch file editor so that we can streamline this process, because at the moment, what happens in GitHub, if you're looking at a diff of a patch file, which is a diff, the GitHub user interface actually gets confused and shows you the wrong highlighting in the UI. Another challenge we faced is that Flutter has two major components. One of the components is what most people are familiar with, which is the Flutter framework and the Flutter widgets. Now, a lot of people, when they think about changes to Flutter, they think of things like the recent change that happened in Flutter, where the Flutter team added a property to allow you to put spacing between rows and columns. Now, those sets of changes are fairly easy because they don't require modifying the Flutter engine. As soon as you have a change that requires modifying the Flutter engine, you have a new problem, which is that the Flutter engine itself is not written in Dart. And it's a fairly lengthy process to go through and build all the different variants of the Flutter engine. And so one of the challenges we faced right away was, how do we put together a process that makes it easier to have a continuous integration running on your own custom Flutter engine variant? Another challenge we faced was, how do we host these Flutter binaries on a CDN? So what happens when you install Flutter is Flutter has what they call an engine hash. And they use this engine hash to download the binaries from a Google Cloud Storage bucket to your machine for the engine version that's needed on your machine. And so one of the challenges we had was, how do we make sure that when we build engine binaries, that the Flutter tool itself, when you install Flutter, can find those binaries and pull them down to the local machine? And then, of course, one of the problems we face is, well, what happens when the Flutter team commits changes that are in conflict with our fork? Because when this happens, of course, we need to figure out a way to resolve these changes and get our fork back to being as compatible as possible with the Flutter team's build, at least so that our builds aren't broken anymore. So what can you do? Check out the Nest tools, and if you're interested in getting a fix quickly out to your users, I think Nest is a great way to do it. It can give you some ideas of how you might want to structure your patches, some tools that you can use to apply those patches, and if you're looking at doing things like custom CI for the engine builds, you can also take a look at our GitHub Actions to help you build all the different versions of the Flutter engine on GitHub. So thank you.